In problem A2, Lily is making a round trip to and from San Antonio. We want to know what her average speed and her average velocity is for the trip. So part of the trip she travels to San Antonio and part of the trip she comes back home. We give you her total speed, or we give you her total distance and her total time there. So again, we have 483.9 kilometers, and she does this trip in 6.53 hours. So clearly the easiest unit to work with here would be kilometers per hour. So that would give us a total of 74.1 kilometers per hour. So that's going to be our answer for the speed, because the speed, she's cruising along this way and then she's cruising back along this way and she's going the same speed. But is she going the same velocity? Well, velocity, of course, has one thing that speed does not, and that's direction. She was going this direction when she was going to San Antonio, but then back this direction when she was coming home. If we call this direction positive, then she's going this direction, we'd have to call negative. It's going the opposite way it was going before. So if we have one positive velocity averaging in with one identical negative velocity, it's going to end up being 0. The other way to look at that is, of course, velocity is really, the D in velocity stands for displacement, not distance. So if this is displacement, we say, well, what was her displacement for the trip? Well, we know distance-wise, she covered this distance. That's how much mileage was racked up on her car. But as far as displacement goes, she started off in her driveway. She drove to San Antonio. When she ended up back home, she was still in her driveway. So straight line from starting point to end point was 0. It would be just like if you just had another car that was parked in your driveway. At the end of the trip, both cars are still right next to each other. So we had no displacement over who cares how much time. That's still going to give me 0 kilometers per hour for the velocity. So that's how we do A2.